Okay, so we're continuing with the C34, which is an Edexcel International paper, January 16. This would be on C3 in the home paper. Well, it looks pretty standard, really. It's not this type of thing is normally quite popular, and they haven't done anything particularly unusual here, so it should be quite straightforward. In this case, what we have to do is just basically test for the root, test F1 and F2 and see if there's a change of sign. And if there is, then we've shown that there is for some point in between fx equals 0. So we work out F1, which is equal to minus 1 cubed plus 4 times 1 squared minus 6. So that equals to minus 3, which is less than 0. F2 is equal to minus 2 cubed plus 4 times 2 squared minus 6, which is equal to 2, which is of course greater than 0. So don't just leave it like that. We're asked to show that it's that. And sometimes students just think that's it, just because they convince themselves there's a change of sign. That's it. You need to finish it. So that means you say something like change of sign. Therefore, there exists a root alpha, let's put it in kind of pure mathematical way, in the interval 1 to 2. Okay, so that's part A. And part B, you just is to play with this, fx equals 0, till we get this expression. Okay, and it's it's not normally particularly difficult to do this. You can even work on this expression, work backwards, obviously, but although it shouldn't normally be necessary, to be fair. So we're solving minus x cubed plus 4x squared minus 6 equals to 0. If I take the 6 over to the other side and also factorize, I get x squared minus x plus 4, and take the 6 over, and that's a 6 there. So that means x squared, swapping the 4, dividing and then swapping the 4 and the minus x as well, so it's 4 minus x. So x is equal to 6 over 4 minus x as required. Let's write that a little bit better, as required. So this is almost like a question to take a bit of a breather in the middle of, well, once you get going, because there's nothing too difficult about this. Now we've got our iterative formula, which they've even given to us based on that, and they've given us a starting value of x1 equals to 1.5. So we could work out x2, we need to work out x2, x3 and x4. You don't need to put your work in all of this, you just need to write down the answers. And I would urge people, I'm sure most people do, but I would urge you to basically use the answer key on your calculator. I'm sure most people are, but just in case, I will demonstrate that here. What you do is you started in red because you certainly don't want, this isn't part of the solution. What you do is you basically, first of all, on your calculator, you type 1.5 equals, and then you basically type, make sure you're in math mode, and type 6 over 4 minus answer, and then keep pressing equals or execute depending on your calculator. Okay, so I've typed all this in now, my calculator, and I'm getting a full calculator display of 1.59193338, but of course it does say give 4 decimal places, so that's what we're going to do. So that's 1.5492 for the first one, and then I'm going to press equals again, and that gives me 1.5647, then I'm going to press equals again, and then I get 1.5696, and that's it. So that's our answer to part C. 3 very easy marks. I've spent a while explaining it, but actually that could be done in just probably about a minute, to be honest. It's not difficult. Now part D is saying, so that 1.572 is a root correct to 3 decimal places. This is the key, because basically it's all back to this change of sign idea again. Suppose we had a root of 1.572. If that's correct to 3 decimal places, then there must be a root somewhere. If I write this on the number line, again, this isn't necessary for your solution, I'm just trying to explain it. So let's do that again. So what we're saying is that it's closer to 1.572 than it is to 1.571, the root is. Remember, the root's lying along this line here somewhere. Okay, it's also quite closer than 1.573. So it will be closer if we're anywhere within this interval here. Needs to be between those two. Okay, so that means that the things we need to test is 1.5715 and 1.5725. So we're going to work out f of 1.5715. Okay, and that is equal to minus 0.00254 and a whole lot of other stuff. And we can say also f of this number here, which is 1.5725, that equals to 0.00261 and a lot of other stuff. This one is less than 0, this one is greater than 0. There's a change of sign. For those who want to do this more formally, we should, although I don't think the scheme really insists on this, but we should say the function is also continuous, because if you have an asymptote or a break of some kind, this doesn't work, of course. But the change of sign and continuous, but I don't think that's actually required by the examiners for C3 and C4, would be in such things as step and whatever, and continuous. So therefore, which that means that there exists that 1.572 is a root of fx correct to 3 decimal places. Okay, so pretty straightforward. Let's have a look at question 6. Okay, question 6 looks like a pretty straightforward exponential and logs question. First part, only 1 mark. It says find the temperature of the piece of metal as it enters a liquid. So in other words, find the temperature when T equals to 0. Now shame on you if you insist on putting 0 into here and working out that this amount would be equal to 1 when T equals to 0. So I should say little t equals to 0, of course. When big T, little t equals to 0, big T must be equal, because that will be equal to 1. So that's 300 plus 20, 320. It's only one mark, so that's got to do it. Okay, let's move on to part B. Find the value of t when the small t when t equals to 180. Correct to 3 significant figures. So we put 180 is equal to 300 e to the minus 0.04t plus 20. I'm probably going to find it exact first before we go any further, but anyway, just switching it around a bit and taking the 20 to the other side, we get e to the 300 e to the minus 0.04t is equal to 160. So e to the minus 0.04t is equal to 160 over 300, and that breaks down to 8 over 15. So I can now ln both of these, so I get ln of e to the minus 0.04t is equal to ln 8 over 15. That gives me minus 0.04t is equal to ln 8 over 15. Now I'm going to pretend this was actually said exact, so that so that we could deal with that, or it said give it in a particular form. So I'm going to change a negative and swap this over, because if I put the negative there and then put the negative there, and then I could put that negative using the rules of logs there. So if I go back to where I started, I can change that there. That's what I had. So I can get rid of the negative that I've just put and call that 0.04t was equal to ln 15 over 8, because I've basically raised that to the power of minus 1, which means it flips. So t, now if I times that by times that by 25, I think. 2005, 25. I've got a nice exact answer for it. It hasn't asked for an exact answer, so I just imagined it said an exact answer, because I don't do that many of these videos, and it'd be nice to just do the question properly, as if it'd be a nicer question if it said work out exact. It gets too many people off the hook when you can use a calculator to get it to 3 significant figures. Anyway, if I work that out, that's 25 ln 15 divide 8, and that gives me the answer 15.7, and we must be 15.7. It cannot be anything else. It's even said give to 3 significant figures. 3 significant figures would be my default position anyway with any of these questions. Right, okay, so now we're doing the differentiation bit for part C. Let's write the expression down. 300 e to the minus 0.04t plus 20. Right, so differentiating big T by d little t will be equal to 300 times by this constant here in front of the t there, e to the minus 0.04t. Okay, so that gives me, well, actually, it's probably better not to multiply it out now, because we need to get it in terms of t, you'll notice. That's dt by dt in terms of little t, but we need to get in terms of big T, so we need to relate it back using this. So it's better not to multiply out, because we can see that if I just maybe write in red, if I take these two bits together, that's 300 e to the minus 0.2t, but we can see from here that 300 e to the minus 0.04t is equal to t minus 20. So I need to, it has said show that, so I need to make sure because I think just writing the answer from here, I think you are perhaps stretching it. It might be okay, but you are probably stretching the bounds of, well, it might be okay, but let's just make it clear, okay? Because a lot of people might not see the little trick that we're doing. So I'm going to write it now this way. Don't multiply out, so that's 300 e to the minus 0.04t. Right, if I write that in brackets, I can now say that's minus 0.04 times by t minus 20. Well, this is 1 over 25 here, so that's basically minus 1 over 25 t minus 20, which we can see, hopefully, obviously. The minus is just going to swap the signs, and I'm going to put the 25 underneath, so it's 20 minus t over 25 as required. Okay, right, so that is question 6 done. I think we'll do one more before we put it into the part 2 of this video. And so let's look at that. Okay, so it's differentiation. It's a combination of C3 and C4. This would be on C3, and this part, which is really quite different, is trapezium rule, would be on C4. I'm amazed that they still ask trapezium rule questions, but there we go. Very easy marks normally. Anyway, let's do part A and B first. To differentiate this, I'm going to use the quotient rule. I think that's probably the way to go. The quotient rule, as I quote it, it is in the formula book used in using function notation. If we're letting this be equal to u over v, then the quotient rule states it's v du by dx minus u dv by dx all over v squared. As I say, there is a version of that in the formula book which you can use to help, but I find that more handy way of writing it. So we've got u equals to 3 ln x squared plus 1, and v equals x squared plus 1. So du by dx, right, we're using chain rule on this because inside here that differentiates, comes to 2x. Okay, so we need to use a chain rule with that. So that differentiated will be the 2x I've just highlighted times by the 3 that's already there, so it's 6x times 1 over x squared plus 1, or 6x over x squared plus 1. And dv by dx is nice and easy, that's equal to 2x. Okay, now we're now putting in the quotient rule, so dy by dx. So we've got v du by dx, so that's x squared plus 1 times by 6x over x squared plus 1 minus u dv by dx, so that's that times that, so that's 2x times by 3 ln x squared plus 1 all over v squared, which is x squared plus 1 squared. Now obviously it's surprising because they haven't said simplifying it. You may well, if you run out of time in the exam and it doesn't say simplify or whatever, it's best to perhaps move on even at this point, because looking at it, it's looking at the mark scheme, that would have got it, but come on, let's simplify it. we don't know what they'll, we can't guarantee that that's going to be the case every time. So that's 6x minus 6x ln x squared plus 1 over x squared plus 1 squared. I'm going to simplify even further because I spot the term in 6x. At 6x, 1, the common factor, 1 minus ln x squared plus 1. And that's all over x squared plus 1 squared. Okay. So now I suppose we might be at an advantage when it talks about part B, that now that we've done this work. We've got dy by dx must be equal to 0 for stationary points. So stationary points dy by dx equals 0. So that gives me all of this equals to 0. Let's write it over here now. That gives me dx, well, not dx, 6x 1 minus ln x squared plus 1 over x squared plus 1 squared equals 0. But of course, in order for that to be equal to 0, we've just got 1 minus ln x squared plus 1 equals to 0. So that means that ln x squared plus 1 equals to 1. So undoing that must mean that this bit here is equal to e, that bit there. So we've got x squared plus 1 equals to e. So x squared is equal to e minus 1. So x is equal to the square root of e minus 1. Okay, be careful though. Sometimes it's good to, you kind of feel like you want to revel in your glory at this point because you're really pleased with your knowledge of logs and everything. Give yourself a pat on the back and you haven't finished the question, because it says write each coordinate in its simplest form. It wants the coordinates. A number of times I see people not work out the y coordinate at this point. Right, so the y coordinate, going back to the original function here. Okay, remember x squared plus 1 equals to e. Let's rewrite that function down. I might just copy and paste it down the page so that we can see it again. So this is our function, and we've got this bit here is equal to e, and so this bit here is also equal to e. So we have y equals to 3 ln e over e. So that's equal to 3 over e. So that's it. But just before I move on, you may be wondering why I didn't put plus or minus, because I didn't have the question up at the time. Perhaps should have pointed out. It does say x is greater than 0. But in fact, we can see there are stationary points at the bottom there as well. So I did a little bit there without actually perhaps being specific. I should have said that x is equal to 0, but that one is not relevant for here because x is greater than 0. So I perhaps should have explained that more clearly at the time. You can't just break things down. I've lost a solution there, but I knew it was okay here because of what we said there. Okay, so I hope that's clear. Right, now trapezium rule. As I say, I don't really, no idea why these questions still, I'm not a big fan. There are other numerical techniques which are more accurate, Simpson's rule, for example, in a lot of cases. But there we go, it's still there. So it is easy marks normally. If we put 1 into here, we're going to get 3 ln 2 over 5. Okay, if we put 1 in there, that's what we're going to get. So let's just do that. Three ln 2 over 2, I mean, of course, 3 over 2 ln 2, so one very easy mark for that. Okay, so that is the trapezium rule. Now, the h in this context is equal to 1, because that's the space in between each bar. Okay, we have a formula in the C2 formula book for which basically boils down to, which can be paraphrased if you like, to this: integral of y dx between the limits b and a are equal to h over 2. I'll write it out. It's something like this. I'll write it out as it's written out in the book. Y0 plus y1 plus 2 times the sum of, not y1, the last one, yn, plus 2 times the sum of all the other ordinates. Okay, having said trapezium rule is easy, I'm probably making a bit of a meal of this, but some people do get mixed up. In the formula book, it also says h is equal to b minus a over n. Well, in this case, n is the number of strips here is actually equal to 3. Okay, it's not the number, it's not 4, because it's all the number of ordinates, which is 4, is always 1 more than the number of strips. Because basically what's happening, if I drew it on here, is we've split this into 3 trapeziums like that. It's not a very good diagram, thinking about it. 3 trapeziums like that. We've got 4 ordinates. 1, 2, 3, 4. Okay, so basically these are this. Let's annotate this. This is the first ordinate. In this case, that's that one. Let's point in the other direction maybe. This is the last ordinate. In this case, it's y going to be y3. And that's what that one. And this is the sum of the middle. In this case, it's only 2 of them. So putting that all in, okay, we get integral b a y, let's write it, the actual thing out, the integral of 3 ln x squared plus 1 over x squared plus 1 between the limits 3 and 0 dx is approximately equal to h. Let's say h is the length between each of these strips, which in this case is 1. This formula is not particularly needed. If you really wanted to do it, 3 take away 0 divided by the number of strips, which is 3. Well, great. So we should see it's 1 anyway. So that's 1 over 2. y0, which is 0, that's that one, plus 3 over 10 ln 10, that's that one, plus 2 times the sum of these two, the sum of the middle ones, that's 3 over 2 ln 2, plus 3 over 5 ln 5. And if we work all that out, we get the answer 1.0397. Well, no, we don't. I was reading the answer from before. We get the answer 2.351. And that is it. So we've spent another 30 minutes on this. I'll try and keep these things short. I always say I'm going to, and then I just start chatting on. Hope you don't mind. Anyway, part 3 coming up hopefully soon. Bye.